Raghuvanshi. In this video, we discuss some question of data science and their answer. Let's start. First question we have: how is unstructured data analyzed? Unstructured data refers to data that does not conform to a predefined data model such as text, images, audio, and videos. Analyzing such data involves transforming it into a structured or semi-structured form to extract meaningful insight. Steps to analyze unstructured data. First, data collection. Gather raw unstructured data, example customer review, image, social media post. Second, data pre-processing. In data pre-processing, clean and normalize the data. First, we have text, remove punctuation, stop words, lowercase conversion, stemming, and lemmatization. Next, image, resize, filter noise, or enhance clarity. Audio, convert speech to text. Next step is feature extraction. Convert unstructured data into structure form using appropriate technique. First, text TF-IDF, word to vec, word embedding. Image, feature vector using CNS, audio, spectrograms or MFCCS. Next, pattern discovery. In pattern discovery, apply machine learning, natural language processing, NLP or deep learning technique. Text, sentiment analysis, topic modeling, entity extraction. Images, objects detection, classification, audio. We have audio. In audio, we have speed recognition, sentiment detection. Next step, we have interpretation. Interpretation visualize or summarize insights using dashboards, graphs, or report. Next question we have: how text mining techniques you can automate the process of classifying written complaints. Automating complaint classification using text mining techniques. Text mining techniques can help us to automate the classification of written complaints by transforming unstructured data into a structured format and using machine learning rule-based approach to categorize them. Steps to automate steps to Steps to automate complaints classification. Data collection. Collect complaint from various sources like email, forms, or customer support log. Now second, data preprocessing. In data preprocessing, first is text cleaning. Remove noise such as punctuation, special character, and HTML tag. Next, lower casing. Standardize text by converting it to lowercase. Stop word removal. Eliminate common word irrelevant like the, and is. Tokenization. Split text into individual word or phrases. Lemmatization. Reduce word to their root form. Example delay to delay. We have an example code of pre-processing in Python. You can see it. Now feature extraction. In feature extraction, bag of bits represent text has a count of bits. T term frequency inverse document frequency. Bait terms based on frequency and importance. Next, embedding. Used pre-trained models like word to wedge, globe, word for semantic understanding. This is a Python code for feature extraction using team frequency inverse document frequency. Now model selection. In model selection, choose a classification algorithm depending on the complexity and size of the data. First, we have naive Bayes, simple and effective for small data sets. Now we have support vector machine, perform well on text classification tasks. Deep learning, use models like RNNs, LSTMS, or transform example word for complex data sets. This is the Python code for naive Bayes classifier. Now we have a automation workflow. In automator workflow pipeline, create an end-to-end pipeline that include pre-processing, feature extraction, model inference. Deploy the pipeline as a Surface X REST API to process new complaints in real time. Next, we have evaluation. Use level complaint to test the model and evaluate metrics such as accuracy, precision, recall, and Epman score. Now, next, we have advanced technique for automation. Multi-level classification. Complaints can belong to multiple categories. For example, delivery delayed and product damage, delivery issue or product quality. Use algorithm like logistic regression with one versus rest, OPR or deep learning models like BERT, topic modeling for unsupervised classification. If categories are unknown, use topic modeling techniques like latent Dirichlet association to discover complaint themes. Now, entity recognition and rule-based system. Combine named entity recognition to identify keywords. Example, delivery delay with rule-based system for classification. Example, this is example for entity recognition. Now, benefits of automating complaints classification. We have efficiency, scalability, and consistency. Reduce manual efforts and processing time. Handle a large volume of complaints. Ensure uniform classification standards. While leveraging these techniques, we can automate the classification of written complaint with high accuracy and reliability. Now, next question. We have considered the following complaint. Suggest the approach algorithm to identify IPC and RNS section to recommend applicable BNS selection section or IPC section. Theft of my mobile phone by unknown person at MG Road on this date. The phone was stolen when I was shopping at a store. The thief was wearing a black jacket and had a scare on face. Now, the approach to solve this problem, firstly, we have to identify applicable IPC section for the complaint. This is the complaint. First, we pre-processing the test. In pre-processing the test, we pre-process the complaint to extract essential element. First, convert to lowercase, remove punctuation and stop words, tokenization and lemmatized word, use named entity recognition. Now, next we have key extracted elements. In key extracted elements, we have theft, crime, mobile phone, object stolen, MG road, location, date, details of theft, thief, unknown wearing a black jacket and scar on face. This is Python code. Now we had feature engineering. In feature engineering, convert the complaint into a format suitable for machine learning or rule-based analysis. Now we have a structured feature. In a structured feature, crime type, theft, keyword theft, stolen mobile, named entities data, date, location, object, techniques, use TF-IDF or word-to-word words embedding for textual representation. Algorithm selection and process. This is a rule-based mapping in which create a keyword to section mapping using domain knowledge of the IPC or BNS. For example, we have theft IPC section 378, mobile phone theft subcategory of IPC section 378. This is the Python code for rule-based mapping. Approach to machine learning. Data set preparation. Collect label complaints with their corresponding IPC and BNS section. Model selection. Train a text classification such as logistic regression for simple classification, random forest for multi-level classification. Or next we have BERT for semantic understanding of complex complaint. Now implementation. Use pre-trained BERT embedding for text classification. This is the code for Python in for machine learning. Now workflow to identify IPC and BNS section. NER for extraction, extract cram type, object and location. Semantic understanding. Use embedding word or word race to match complaint with like legal section. Now classification model. Train a supervised model on label data to recommended appropriate section. Now validation. Use cross validation to assess performance. Now applicable IPC and BNS section for the complaint we have applicable IPC section 378. Whenever whoever dishonestly takes any movable property out of the possession of any person without their consent. Now we have possible broad national category BNS section 101 theft related offense. Now metrics to evaluate the system. Precision. Percentage of correctly identified section among all recommended section. Now recall. Percentage of applicable section correctly identify the system. Now we use F1 score harmonic mean of precision and recall. Now confusion matrix. Analyze true, positive and false negative. By following these operations, the system can recommend an IPC and VNS section for the given complaint with accuracy and consistency. Now move to next question. We have suggest a suitable data structure for an algorithm for question 3. The suitable algorithm and data structure for question 3 we need to choose whether the data structure and algorithm that enable efficient processing, analysis and classification of textual data. In this, we have data structure, text representation, In this, we use bag of butts represent text as a vector of butt counts. Now, TF-IDF, based on frequency and importance. Now, next, we have embedding. In embedding, use dense vector representation. Example, globe butt for semantic understanding. Now, next, we have a dictionary and HashMap. Store mapping between keywords and IPC and BNS section. Example, theft, IPS, stolen, and IPC 378. Now tree, prefix tree, store keywords for fast matching. Example used to match phrases like mobile phone theft. Now next we have graph, represent relationship between entities. Example crime type, applicable section. Now we have algorithm, rule based mapping, use keywords matching to map complaint to predefined section. Example theft map to IPC 378. Now next we have text classification, supervised machine learning, logistic regression, naive based for smaller data set with feature based representation. Example TF IDF. Now next we have deep learning. In deep learning, word or LSTM for semantic understanding of complex complaint. Example fine tuned word for text classification task. Now next we have named entity regularization. Use NER algorithm like SPACY, Stanford, LLP to extract entities such as crime type, date, and location. Now we have similarity algorithm. Use cosine similarity to compare the complaint text with the description of IPC and BNS section. Example match complaint embedding with pre-computed embedding of legal section. Now we have multi-level classification. In multi-level classification, handle cases where complaint may map to multiple sections. Example algorithm, we have used a random forest with multi-level support but with multi-level classification. Now next we have question suitable metrics for assessing performance in text mining. Evaluation for question 3. Precision and recall. Evaluate how open the correct IPC sections are identified. Confuse metrics. Analyze case where the model misclassify or misses with certain section. Now analysis. Check for pattern in misclassification. Example, if robbery is mistaken for theft. By using these metrics, the performance of algorithm can be rigorously assessed and optimized for better accuracy and reliability in text mining tasks. Thank you for watching the video.